Okay, this video is about factoring special products. And in this video, we are going to be factoring perfect square trinomials and also learning about factoring the difference of two squares. First of all, how can you tell if a trinomial is a perfect square? Well, it's a perfect square if the first and the last terms are perfect squares. So you're going to look at the very first term. Okay, like here we have a 9x squared and the last term, which is a 4. 9 and 4, as well as x squared, are perfect squares. Now, the middle term needs to be 2 times one factor from the first term and one factor from the last term. So, the factors for my first term were 3x, and the factor for my last term was 2. To check the middle term, I need to see if the middle term is 2 times 3x times 2. Okay, so, and in this case, 2 times 3 is 6, times 2 is 12x, so this time it matches up. It is, in fact, a perfect square. So here's the rule for perfect squares. Okay, when we're factoring, and this is really important, make sure you write this rule down. A squared plus 2ab plus b squared factors into a plus b times a plus b, or a plus b squared. So like the previous one we were just looking at, let me just write that down again. So on the previous page we were talking about 9x squared plus 12x plus 4. What we have to do is look at the first term, and we decided that 9x squared is 3x times 3x gives us 9x squared. Okay. And then what times what gives me 4? Well, that's 2 times 2. So 4 is 2 squared. So now I check my middle term and I take the 3x times the 2 and multiply that by 2. So is 2 times 3x times this 2 from the other side equal to 12 plus. And yes, so since that works, we can write this as a factor. We're going to take our first one and our last one, and we write it in factored form as 3x plus 2 squared. Alright, let's see if we can determine whether each trinomial is a perfect square. And if it is, we're going to factor it. And if not, we're going to show why it's not a perfect square. So looking at the first one, what times what will give me 9? Well, 9 is 3 times 3. And what times what gives me x squared? Well, x times x is x squared. So 3x squared will give me 9x squared. 3x, the whole quantity squared, gives me 9x squared. What times what gives me 64? 64 is 8 squared. Now I check my middle term. The middle term needs to be 2 times the first one, which is 3x, times the last one, which is 8. Okay, is 2 times 3 times 8 equal to 15? So this is not in fact equal to 15, so this is not a perfect square. Okay, and the next one. What times what gives me 81? 81 is 9 times 9. What times what gives me x squared? That's x. So 81 times x squared is equal to 9x quantity squared. What times what gives me 25? Well, that's 5 squared. So now I check my middle term. Is the middle term equal to 2 times the first one, which was 9x, times the last one, which was 5? And here we have 2 times 5 is 10, times 9 is 90. So this time it works out. This is a perfect square. So now to write my answer, I take the first one and the last one, and I write my perfect square, this equals 9x plus 5 squared. Okay, what times what gives me x squared? That's x times x, x squared. And what is 49? That's 7 times 7. Checking my middle term, is it 2 times the first, which is x, times the last, which is 7. 2 times 7 is 14, so this also works. Now when I write my answer, I'm going to use my first one and my last one. So I'm going to have an x and a 7 squared. This time, since the original problem had a minus in it, I need to put a minus between these two. Okay, and last one times what is 36? We have 6 and x. 6x squared gives us 36x squared. And what times what gives me 14? Well, 14 is not a perfect square. Okay, we would get a decimal. We would have to do square root of 14 here. So that's not going to work. It's not going to give us a whole number. So this, because the 14 is not a perfect square, this trinomial is not a perfect square. Okay. The next kind that we're going to do is difference of two squares. So the difference of two squares, when we're factoring this, it has the form a squared minus b squared. And when you're factoring them, it can be written as a product, a plus b times a minus b. So we can use this pattern to factor some trinomials. So a polynomial is a difference of squares if there are only two terms. Okay, so this is only going to work when we have one thing and another thing. It has to be a binomial, only two terms. And it has to be subtracted. Okay, so we have to see a subtraction sign between the two. This will not work if it's a plus. And the two terms that we have both have to be perfect squares. So in this case, 4 is a perfect square and 9 is a perfect square. Okay, so if those things are true, then you can use this rule to factor as a shortcut. Okay, and here's the rule that we're going to use. A squared plus b squared factors into a plus b times a minus b. So on the example on the previous page, for x squared minus 9, we would say, okay, 4x squared is 2x squared, and 9 is 3 squared. So this factors into 2x plus 3 and 2x minus 3. Plus 3 and 2x minus 3. Okay, and looking at some examples of that. Okay, let's determine whether each binomial is a difference of squares. And if so, we'll factor it. And if not, we can show why it doesn't work. So, for the first example, okay, now the 9, I know that 9 is 3 times 3. What times what will give me q squared? I mean, q to the 4th. Well, q to the 4th, remember that when we are multiplying, you add exponents. So if I had q squared times q squared, you would add those two exponents and get q to the 4th. So q squared is q to the 4th. So that's q squared and then squared. Now when we're multiplying like this, we would when it's a power, we would multiply these two exponents. 2 times 2 would also give us the 4. Okay, so because 3 is not a perfect square, this first one is not difference of squares. Now on the next one, p to the 8th power. Well, p to the 8th is p to the 4 squared. And 49 is 7 squared. Q to the 6, well, we can write q to the 6 as q to the 3 squared. So 49q6 becomes 7q to the 3rd squared. So they're both perfect squares. So to write my answer, I have p to the 4 and I have 7q cubed, 7q to the third power. So I'm going to write my answer p to the 4 plus 7q to the third, p to the 4 minus 7q to the third. Let's do another example. So in this next one, what times what gives me 1? Well, 1 times 1 is 1, so here I have 1 squared. What times what gives me 4? 2 times 2 is 4. And what times what gives me x squared? Well, x. So 2x squared will give me 4 times x squared. Okay, so now I can write my answer. My answer will be the 1 and the 2x. So my answer is 1 plus 2x times the quantity 1 minus 2x. Let's look at 16. 16 is, the square root of 16 is 4. And what times what gives me x squared? X. So 4x squared will give me 4x quantity squared will give me 16 times x squared. Okay, what times what gives me 4? That's 2. What times what gives me 5? Okay, well, 5 is 1 times 5, but I cannot break it down into 2 equal things that are multiplying to 5. So because this is not an even exponent, I'm having difficulty here. So the exponent has to be even. So because of that, this is not a difference of squares. Not a difference of squares. All right, great.